Yes, when we add all these angles, that should give us 180, right? So when we are going to
Yes,
have 5x plus 20 is this first one here. And then I'm going to have plus the second rotation there is that one. So I'm going to have 2x minus 10. And then the third rotation there is plus x plus 10. They're equal to 180. And then we are saying they are in sum of, let's say interior angles of a triangle, right? And then we have like terms in this case. Our like terms, let's quickly check. We have 5x plus 2x
2x,
plus x. So when we add all of them, we're then going to have 8x, right?
8. Yes.
And
yes,
then we have another like terms, which is, I will use a different color. Plus 20 minus 10, it is positive 10. Plus 10 is
Plus 10.
20. So we're going to have plus 20 here is equals to 180. Then you take the 20 over to that other side. So finally, we're going to have 8x is equals to
Equals
180
180
minus 6,
minus
minus
20.
20, not minus 60, minus 20. And then 8x
it's
is
equal
equal
to
to 160. We divide both sides by 8. So our answer
8,
in this case is how much?
20.
Our x is 20.
20.
Like I said,
Sharp, sharp, okay?
yes, sir.
But again, remember, in this case, we know how much x is. We only know how much x is. We don't know how much the angles are. So now let us find
Yes.
how much those angles are. So for the first one there, we know that we have 5 at the place of x. We're going to have 20 plus 20, that first rotation there. So how much
Which is going to give you 120.
is it? 120.
Yes, sir.
Yeah.
Yes.
So here is 120 degrees. And then let us look for this rotation. How much is that rotation now?
That one
This rotation. Because here we're going to have
is 30.
2 times 20 minus 10, or is 30, right? So here is 30.
Yes, sir.
That angle there is 30. And then similarly with this last one here,
It's 30.
it's also 30, this
It's also
rotation here.
30.
Because 20,
Yeah.
that x, 20 plus 10 is going to give us 30.
30.
What can you guys tell us about these angles? Let me just have them different.
It's a isosceles triangle, two angles
Yeah,
are equal.
Similar.
they are equal, right? Those two are equal.
Yes,
Yeah.
Meaning we're going to have
Two.
them as isolated. So if this is 30, if this side is 30 degrees and also that side is 30 degrees, it means that if this side here is 20, it means this side is also going to be 20
20.
20
because they are isosceles.
triangle.
Triangle.
Yes. But let's quickly check if, oh, they said the length of AC, we got it, which is 20, okay?
Yes, sir.
The length of that. And then now we come to this one here. For this one, they're saying triangle ABC, it is congruent to triangle EDF. I mean EDC. They're saying that congruent. What does congruent mean? It means that
They're similar
Yes.
to each
it
other.
means that this angle here, remember A, it corresponds with what? With E, right? That's what they're saying. If they're saying they're congruent, it means that A, it should be equal to E, meaning the value of A, it is equal to how much? 35,
E-
because their E is also how much? 35.
35.
35.
Yes.
So what if I said corresponding angles?
No, that's wrong. Oh, okay. You can say because triangle
But
ABC is congruent, and then you say because they are corresponding angles. You can't just say they're corresponding angles just like that. Remember, corresponding angles, we normally use it on the basis when we have parallel lines, right? But here you must
Yes, sir.
imply that they are congruent, therefore corresponding angles, not just corresponding angles like that. Be specific.
Okay.
And I
Yes, sir.
say BCD. BCD is a straight line. BCD, a straight line. ACD is also a straight line. Find the unknown angle and side marked in a diagram.
C.
So we know how much A is, right? We already said it.
Yes, sir.
A is
Yes.
5, and then we said, okay, let's just write it up here. A is equals to
35.
35. The reason is that triangle ABC, it is congruent to triangle
EDC.
EDC, right? That's our reasoning.
Yes.
And then we can therefore say corresponding angles. Are we fine? And then we have, what
Yes.
else do we have? Then we're going to look for C, right? Because that's another side, the length. So the length there is how much? How much is that length?
3 centimeters.
3 centimeter.
So C is equals to 3 centimeter. Our reason is what?
A
Triangle ABC is congruent to
is
triangle
congruent.
EDC.
EDC
Therefore, they are what? Corresponding sides.
sides.
So that's how we should mention it. But when we don't just say they are corresponding angles or corresponding sides, no. We must be specific. Then we come to this one here. That's saying in a diagram below DE, line DE, it is parallel to line AC. BD, it is 8, 80, 8, 8. Okay, fine, we have that. And then they're saying prove that these things are they're similar. Prove
Congruent.
that triangle BAC, BAC is the big one, right? That big triangle there. So let me draw
Yes.
using a different color. The big one. We have that. This is B, B, A, C. That is that big triangle, like this one, the big
Yes.
one, BAC. So how much is AB or BA? How much is this side? This side,
8.
how much is it?
12.
It is 12 because we have to add
12.
the 4.
4
And also,
plus 8.
okay, is that side. So this side is going to be 12,
12.
right?
Yes.
Yeah.
Is there anything else we know?
Yes, sir. No.
DE is
Parallel.
parallel to AC.
We only know
And they
that.
parallel.
Okay, that's all we
Mhm.
can say we know. Because, and then we have another triangle. The other triangle that we have is that small one. I will just use a different color as well. That small one is inside this one.
EDE.
It's inside, I guess. That I'm drawing it there because it's inside. It's inside. So we have B, D. I will write B again so that you can see that B it is both green and red. So B, D, E. Those are our two triangles, I guess. And then remember they said these two are parallel. So I think we should prove this. How can we prove this? We know by now that when we have parallel lines, we can say that this angle here, it is equal to that angle there, I guess.
Yes.
What is our reasoning for that?
Co
The corresponding. That was
triangle.
correct. The corresponding. So how do we name it? We can say angle BDE. Remember, moving from B, then D,
So you
going
can
to
write
E.
the angle sign.
And then we say it's equal to which angle now? Angle BAC. It is equal to that angle,
Yes.
right? Is equal to angle BAC.
AC.
Our reason is that they are corresponding angles because line DE is parallel to line AC.
AC.
So now What else can we spot here? We can say that this angle here, it is also equal to that angle there, right?
Yes.
Angle there is equal to that angle. Our reasoning for this is what?
Corresponding
They're also
angle.
corresponding. So now let's name them. So this one here, it is B, E, D. I guess BDE. And then this angle here, it is BCA. BCA as well. I'm saying they are corresponding angles because DE, it is parallel to AC. So now we're only left, remember this is angle, and then we have another angle. Remember, if we get the third angle, angle, it means they are what? Similar, right? For
Yes.
similarity, if we get angle, it means they are similar. And then we have this angle here. That angle is both for what? For the red triangle and also for the what? The green triangle.
Triangle.
So it means that angle there, it applies to both the triangles, meaning it is equal for both triangle, the red triangle, and it's also for the red. So we can just say angle
B.
ABC, it is equal to angle ABC. And what's our reason for this? They are what? A common
Correspond.
angle. They are common angle because that angle applies to both the triangles. So now in this case, do we have what we needed? A.
Yes.
Angle. So when we have angle, then we can say, therefore, triangle BAC, it is parallel. I mean, it is similar to triangle BDE. Once we've proven that, okay?
Yes.
So once we know that these triangles are similar, then the second part comes in. That second part is that it means the proportion of the sides, it should then be equal. What do I mean by that? I mean that I'm going to draw those triangles again, that big one. We know by now, we just proven that this big triangle, which is triangle ABC, I'm going to take that small one, I'm going to throw it outside. We know they are similar, but this one is DBE. We know we can just, if we want, we can take this triangle and then put it inside, and then it will look like that big drawing, right? So, but then we decided to draw it outside. So we said previously that from A to B, it is 12. And then how much is it from B to D? How much is it from B to D?
B to D.
It's 4.
It is 4,
4.
right? So we know here it is 4. And then BE, how much is BE?
8.
8.
I mean,
Is
yes, 8.
8. Do we know how much BC is?
BC.
Yeah, from here all the way there. Do we know how much it is? We don't know,
No.
right?
No.
We only know that from there to there it is 8, but we don't know how much it is all the way down. Correct?
Yes.
But we also know that this side, it corresponds with that one. So when we say AB over DB, it will be equal to when we are saying this side, which is BC and BE. So when we say it should be equal to, the other one is BC over BE. And then lastly, when we say this one here, it should also be corresponding to that one, let me use rather three things. So we have AC over DE. So remember this all the time. If ever we've proven that those two triangles are similar, that statement should be true all the time. So now on our next question, that is where we're going to apply that. When they're saying to us, we should find the length of EC. The length of EC is this length here, EC, from down here, from here. Let me use blue. From here to there, they're saying we should find that length, right? Then what we then do is we say, let me erase here so we can have enough space. What we then do is we know how much AB is. We know how much AB is. So our AB, we think our AB is 12. Over, we said BD is 4, right? It is equal to. Then we said we don't know how much BC is. That whole length, we don't know how much is it. So we're going to write it as BC over that small one that we know how much it is, which is 8. And then
8.
from here, then we solve for BC. So we cross multiply. So we're going to have BC 4 BC 4 BC. 4 times BC is 4 BC is equals to 12 times 8. How much is that? 12 times 8. How much is that quickly?
96.
96. Then you divide both sides by 4. Then how much is BC?
24.
24. So now if from here all the way down there, if from here all the way down there it is 24, and we know that from here to there it is 8, then how much is it from here to there? How much now? How much is that?
60.
It's going to give us
16.
right? Because when we add 16 plus 8, it then gives us how much? That 24. So finally, we then say, therefore, that length, which is EC, is going to be 24 minus 8. Therefore, EC is equals to 16. That's how we go about it. Any question? Okay, next question. Then we come to this one here. They're saying PQRS is a parallelogram. The last time we were in class, we spoke about this thing. When they say something is a parallelogram, we should already assume in our minds that these sides, the opposite sides, are equal and parallel, right? So this is equal and parallel. And also, let me just use a different color, that this side here, it is also equal and parallel to that side.
Parallel.
So that we should always assume. That's what we should always assume. So they said this side, this here, it is 8. So it is 8, meaning this side is also 8 centimeters, meaning here it is also 8 centimeters. It means this side is also 8 centimeters because they showed us that with the marks that they are all equal. Right? They showed us. Let me just remove this so you guys can see that. You see, they made that one mark. So this one mark, it means they're equal, right? It means that, and we also know that opposite and equal, meaning here it is also going to be 8 centimeters. That we should always know. And the other thing that we should also know is that looking at this, I will use this color orange, this triangle here. What kind of a triangle is this one? That has all the sides equal.
Equal.
Equilateral
It's an
triangle.
equilateral triangle, I guess. And remember, an equilateral triangle, it means that all the angles inside of it, they're equal
Are
to,
equal.
because when you add all of them, 60 plus 60 plus 60 is going to give us 180. So that we should remember. And one last thing, remember that the opposite angles of a parallelogram, they are also equal. So if we have 60 there, it means this angle here is also 60.
60.
So don't forget that. Don't forget that. Right, so the first question was for us to calculate Q. So already I showed you guys how we found Q, but this is how we're going to write it. We'll write there that a triangle PQT, which is that orange triangle, it is equilateral, okay?
Yes, sir.
Equilateral triangle. And then how did we say that? We know that PQ, that side, it was equal to 8 centimeters. It was given. They showed it to us. And also TQ, TQ, it was also 8 centimeters. The reason is that we saw that it was given. Therefore, it makes that triangle to be an equilateral triangle. And we know that all the angles, each angle on equilateral triangle is equals to 60 degrees. So that's how we got it. Okay? So that's the first one. And then they said we should find angle R. Angle R is this angle here. Is that angle there? That is angle R. Let me use a different color. That is angle R. But before we go to angle R, can we find how much angle P2 is?
Yes, sir.
How much is angle P2?
60.
Angle P2. In fact, let's say angle T1, that angle there, it is equal to angle P2, right?
P2
Because they are
corresponding.
alternating angles. They are alternating angles because SP, it is parallel to
RQ.
RQ. So now, when that is the case, then we need to know how much is that whole angle there. How much is now this whole angle here? How much is that whole angle? Angle P. How much is angle P? The whole of it? 120, right?
120.
Yes. Then we say, therefore, angle P is equals to angle P1 plus angle P2, which is 60 degrees plus 60 degrees. And then this gives us 120 degrees. So if this whole angle here, it is 120, how much is then that angle there?
120.
120 as well. Therefore, we say angle R is equals to angle P. Why? Because they are opposite angles of a parallelogram. Remember I said opposite angles of parallelogram are what? Are equal. Right? That's why we are saying that angle R it is also equal to 120. Therefore, this, let me just write it here. Therefore, angle R is equals to 120 degrees. That is how we go to that.
Yes, sir.
Yes. And then is there another question? Okay, angle R. And then they said we should find angle S. Angle S, I told you guys. So what was the reason behind this angle being 60 degrees?
Summer for quadrilateral.
It's a question. What do you know about the opposite angles of it, or opposite angles of a parallelogram?
They're equal.
Yeah, equal. So you can simply say angle S, angle Q, angle Q is equals to angle S. The reason is that they are opposite angles of a parallelogram. Therefore, angle S is equals to 60 degrees. Done. One, you don't have to do like big calculation. And then we come to this one now. They're saying consider triangle PQS. Triangle PQS. We should consider triangle and RSQ. And RSQ. SQ, that one there. We should consider it. Right? They're saying we should
Yes, sir.
prove that they are congruent. So from the first one there, we can see that they gave us that this angle here.
So I can ask a question.
Hmm?
When we say congruent, is it like another word for equal or something?
It means that they're equal in size and shape. They look exactly the same and they're exactly the same shape,
Well,
same size. So now we can see that this angle there, the one that I marked, it is equal to that one, right? They gave it to us
yeah.
by that
Yes.
using those dashes. So we can simply say that angle S2, it is equals to angle Q2. I guess it is given. We not look for it, it was given. And then the other one that's saying this side here, it is equal to that side, it is also given, which is side PS, it is equal to side QR,
QR.
also given to us. So here we have an angle, here we have a side, so we need the last thing. And remember, for us to prove congruency, we need to at least have all the three sides determined, or two sides and one angle, or one side and two angles, right? Or we have a right angle, a hypotenuse, and a side. So at least at the moment we have one angle and one side. So we have one side and one angle, meaning we can either use this one or that one. But for us to use this one, it means we need another side. For us to use this one, it means we need another angle.
Angle.
There.
And
Yeah,
then we
sir.
can clearly see that from these two,
We have an angle on the side.
here, this side, it is both for what? For the two triangles, right? That side it applies to both the triangles. The red, it
Mm.
applies, that side, it applies to this triangle here, and then it also applies to this triangle here. Meaning that side is a common side, it applies to both triangles. So we can therefore say that this was first one, number one. Number two, we can clearly say QS, it is equal to QS because it applies on both the triangles. And then we are calling it a common side
Side.
because it applies to both of them. So now we have what? Angle, side, side. We're not going to use that reasoning there. Then we can say, therefore, triangle PQS, it is congruent to triangle RSQ. And our reasoning is that we have now in this case side, side, angle.
Angle.
That's how we got to it.
Mm.
And I think that would make our last question. Yes, that would make our last question. And then in the meantime, please try to do question 4. I don't know, Tebo, maybe if you said question 5 is harder, but question 4, I don't think it's harder at all. So when you have time, also, and then maybe while you are busy waiting for me, please go through question 4, and then
Oh,
just try to go through it. Question 4. Just try to go through it and see what you can
Sure.
do. And then also I know when we meet tomorrow at 6 o'clock, we'll go through question 4 and 5. And then I think we'll be prepared
yes.
to write our
Yes.
exam on Friday,
Sir?
on Wednesday.
Sebabis.